Hey everyone, welcome back. In this lesson we're going to continue talking about the same thing that we'd started in the last video, which was algebra problems involving two variables instead of just one. So I think at least for the time being we're going to skip out on doing word problems. We'll just focus on doing the math. So this video for sure will just be more of the math, and then we'll see in the future if I change my mind about the word problems, but we might just skip over the word problems for this unit, and we'll move right along once we get comfortable, once we get a little bit more comfortable with the math that's going on here. So let me just throw on a title here. So we're doing more practice, or more problems. Let me do more problems involving two variables. I'm going to have to squeeze that in. Alright, so, alright, I think we just barely made it over there. Alright, so yeah, more problems involving two variables. So in this one, it'll be very similar to the last video. We're just going to go through a few different examples. I'm going to give you, we're going to try and go through 4 examples today. We're going to jump right into that in a sec. But yeah, it's going to work just the same as the last video. So we're just going to go through, I'm going to give you 2 equations, and then we're going to work through the problem and solve for the 2 variables, so x and y. Now again, on a test, especially if it was a word problem, you're free to call the variables whatever you want, and maybe for variety later on, when we're doing more practice problems, I might change up the variable names, but for now we'll just keep it at x and y, and we'll get through as many of these problems as we can today. So I'm going to just get rid of that title actually. I threw it up there, but we're going to need all the space we can get for these problems if the last lesson taught us anything. So let's get right into it with the first problem here. So the first one that we're dealing with. So again, I'm going to number them with Roman numerals. So to begin, your first equation. First equation is going to be 15x plus 27 is equal to 3y. Alright, 15x plus 27 equals 3y, and your second equation is x equals 2y. Alright, so those are our 2 equations for this problem. So now if you remember, the way we have to start this is either we have to rearrange equation 1 or equation 2 so that we've got one of the variables by itself on one side of the equal sign. Now in this particular case, that's already been done for us in equation 2, right? We've got x already by itself. There are no numbers attached to it and no y's attached to it. So we already know x is exactly equal to 2 times y, or basically x is double whatever y is. So what we're going to do is we're going to sub equation 2 into equation 1. Alright, so basically we're going to use equation 1, we're just going to slightly modify it in that anywhere that we see x, we're going to replace it with 2y, because we're going to try and express that entire first equation in terms of just the variable y. So if we go ahead and do that, so if I rewrite, for now let me just rewrite the first equation. So we've got 15x plus 27 equals 3y, but hang on, we don't want to have the x in here. So I'm going to get rid of this x, we're going to replace it with 2y, because we know that that's what x is equal to. So I'm going to throw in brackets there, 2y. And so there we go. So we've got, using equation 1 for the most part, it's 15 times 2y plus 27 equals 3y. Alright, so if I go ahead and I do the multiplication here, 15 times 2 is 30, so I'll end up with 30y plus 27 equals 3y. Alright, now just like when we were working with a single variable, we want all the terms that involve the variable on one side of the equal sign, and all the numbers, all the terms that don't involve any variables, on the other side. So what I'm going to do is I'm going to bring this 3y over, and so that'll become negative when I bring it to this side. And I'm going to take this 27 and I'm going to chuck it over to the other side, and it'll become negative when we do that. So if I go ahead and I do that in the next line, we end up with 30y, nothing changes. When we bring this 3y over, it's going to end up being minus 3y equals, and then on the other side, this 27, when we throw it onto the other side, it becomes negative 27. Alright, so now we've got everything that involves y on the left side and everything that doesn't involve y on the right side. So we can now condense this down a little bit. 30y minus 3y, that's like 30 bananas minus 3 bananas is going to leave us with 27, so that'll be 27y on the left is equal to negative 27 on the right. And if we divide both sides by 27, we'll be left with just a y on the left side, and we'll be left with negative 1 on the right side. Or the other way that you could think about this is 27 multiplied by what number is going to give me an answer of negative 27. And so the answer to that question is that the number you're multiplying 27 by has to be negative 1 if you want to get an answer of negative 27. So there we go. We've just gone ahead and solved for y. And now we're going to use this information. We're going to throw it back into equation 2 to solve for x. So I'm going to box this off here. And then using equation 2, we've got x is equal to 2y. But we know y is equal to negative 1, so x is equal to 2 times negative 1. So x is equal to negative 2. Alright, so hopefully that's a simple enough problem to start off the day. So we've gone ahead and, just to recap, we used the first equation. It doesn't necessarily matter which equation you use, it just so happened that in this particular question it worked out this way. But we ended up using the first equation. For the most part, we subbed in this fact from equation 2 right there. We replaced x with 2y, that came out of equation 2, but the rest of the equation came from equation 1. So for the most part we were using equation 1, used that to solve for one of the variables. In this case we solved for y down at the bottom, and then we took that information, we figured out what y was, we subbed that back into equation 2, and we solved for x. So we did end up using both equations. We started by mostly using equation 1, and then we ended up using mostly equation 2. Alright, hopefully that's making sense and is sort of in keeping with what we were doing last time out. Now, so far our answers, for the most part, I could be wrong about this if I've forgotten one of the questions from before, but I think for the most part the numbers that we've been getting as our final answers have been quite small. And we'll do one that's not necessarily a more complicated problem, but just involves some slightly larger numbers, and we'll see if our variables still come out to small numbers, or big numbers, or one small and one big. So let's go ahead, we'll throw in a second one now. So we've got, let's see, we've got, here we go, 331x on the left side. 331x is equal to y minus 22x. Now I was debating on rearranging equation 2, but just for the sake of saving space, I'm going to leave it the way I initially wrote it down. And so that is going to be y is equal to 333 plus 20x. The rearranging that I was considering doing was messing around with equation 2, so that we have to do a little bit of work, but we have to do a tiny amount of work on the next problem. And let's be real, on the assignments and tests, I'll probably just make the second equation one where you don't really have to do very much with it, so we won't worry too much about those types of equations right now, where you have to do a lot of work with one of the equations. So with this one, we've already got what y is equal to in terms of numbers and x's, right? So we've got it in terms of this number 333 here, and this thing depends on 20 times x, so it depends on whatever the value of x is over there, but it doesn't depend on anything else. It doesn't depend if there are no y's on that side. We don't have to do anything to this second equation. It's fine exactly the way it is. So what we're going to do is we're going to sub equation 2, so that's the second one down here, back into equation 1. So basically anywhere we see y in equation 1, we're going to replace it with this big thing. So this is definitely bigger than what we were dealing with in the last question. So let's go ahead and throw that in. So we started with 331x on the left side. That doesn't change. Now after the equal sign, before we had a y here, but we know y is equal to this big thing, this 333 plus 20x. So we're going to write that in instead. So we're going to put in 333 plus 20x. And then from before, we still had this minus 22x left over up top. So I'm going to throw that in as well, minus 22x. Okay, so now, if we look at this, we've got everything sorted out in terms of x's and numbers, constants. Right, so what I'm going to do is I'm going to start off by grouping together the x's on that side. I'll leave this one alone for now. So we've got 331x is equal to 333 plus, well, actually it's not going to be a plus sign because we've got 20x minus 22x. That's like 20 apples minus 22 apples is going to leave us with negative 2 apples. So I'm going to have to do, I'm going to have to put a minus sign here, so it'll be minus 2x, because if we go ahead and do this subtraction right here, we'll get an answer of minus 2x at the end of it. So that's where we get that minus 2x over there. Now we can bring this minus 2x over to the left side and add it on to this 331. So we end up with 331x plus 2x is equal to 333. Now obviously doing this addition, we're going to get that 333x is equal to 333. You might see that I was a little bit lazy when I was making this problem, in that I wanted the answer to be quite a simple one for x. So basically we're asking here, what number do I have to multiply 333 by in order to get an answer of 333? The other way you could think about it is, in order to get x by itself, we divide both sides by 333, and we'll be left with x is equal to 1. Alright, nothing too complicated over there. So even though we had big numbers kicking about in our equations up here, x turned out to be a really small and simple value. But now, so that was mostly using equation 1. Now we're going to use equation 2. So we're going to rewrite equation 2 over here. So that's y is equal to 333 plus 20x. But we know x is equal to 1. So I can rewrite this as y is equal to 333 plus 20 times 1, which is the same thing as just 333 plus 20. So we get 333 plus 20. So that tells us that y is equal to 353. So there it is. We were dealing with larger numbers in the equations, and we ended up with a small answer for our x variable and a huge answer for our y variable. Hopefully you can see it down here. We've got 353 down here for what y is equal to. Alright, so the thing I want to point out here is that it matters which variable has which number corresponding to it. You can't just swap around x and y willy-nilly, even though they're both variables, because these equations up here have them placed very specifically. If you have these two equations and you're working with them, x has to be a really small and simple number, which came out to be 1, and y tends to be far more complicated, as it was in this problem at 353. Now you could have other problems that are set up differently so that y is a small number and x is not. You could have problems where they're the same value but one of them is negative, so like 4 and negative 4, and those things can make a difference in the problem. So so those are just things to be watchful of, is that make sure you don't accidentally swap out one variable for another while you're working through the problem, because the variable that you're using at a given time really makes a difference and it really matters. Alright, so I've completely forgot to put that this was problem 2 up here, so let me, just before we get rid of that, there's problem 2, that's the one we just did, and now we're going to move on to problem 3, so I'm going to add another tick in that circle over there before I throw problem 3 up on the board. So this next one is, again, it's not overly complicated. We're going to have to do a tiny bit of work with one of the equations, but just in the, for the sake of saving space on the whiteboard, we kind of barely squeeze in the answer here without erasing anything. I've tried to keep the rearranging really, really simple. So for this next one, so this will be number 3, so if I extend that over there, so we've got question number 3 now. So your first equation here is going to be y is equal to 343 minus x cubed. Alright, so this is a little bit different from what we've seen before. And your second equation is 7 minus y equals 7. Alright, so we have to do a little bit of work, or you could just look at one of the equations and get some information out of it. So if we look at equation 1, that's a little bit of a mess right now. We haven't really dealt with x cubed very much, if at all, and there's nothing else to really help us, write x in terms of anything else, so we'll just leave equation 1 the way it is. But if we look at equation 2 down here, 7 minus y equals 7. That is basically asking, if you start with 7 and you subtract y, whatever that is, and you're still left with 7, how much did you subtract? What do you have to subtract from 7 in order to get 7, right? What do you have to subtract from 7 to get 7 as your answer? So we can clearly see from this that y has to equal 0, right? 7 minus 0 equals 7. 0 is the only answer that'll make this true. The other way you can go about solving it is take that y and throw it onto the other side. It's negative on the left side, so it'll be positive on the right side. And we'll take this 7, which is positive over there, we'll throw it onto the left side. And it'll, because it's positive on the right side, it'll end up being positive, or it'll end up being negative on the left side, excuse me. And so we'll be left with 7 minus 7 equals y. 7 minus 7, that's just 0. So we get y is equal to 0. Alright, so this is a crucial piece of information that we've got out of equation 2. And we actually don't really need to go back and solve things at the end, because we've already gone ahead and, using equation 2, solved for y. We know y is equal to 0. And so this must be true. If these two equations are linked, it must also be true that y is equal to 0 in equation 1. So if we sub y equals 0. You could call that equation 3 if you wanted, or you can just say subbing in, like the fact that we know that y equals 0 into equation 1 means we can rewrite that exact same thing, but instead of y on the left side, I'm going to put a 0, because we know that y is equal to 0. So we get 0 is equal to 343 minus x cubed. Alright? And so this will allow us now to solve for x. We've already solved for y. We've got one equation left. We've got one variable left. And so now we can go ahead and solve for x. So I don't know about you guys, but I don't like having unnecessary negative signs. So what I'm going to do is I'm going to take this x cubed, I'm going to throw it to the left side of the equal sign, just so that it becomes positive. So I'm going to I'm adding x cubed to this side, and I'm adding x cubed to this side. So what that's going to leave me with in the next line is I'm going to have positive x cubed on the left side is equal to 343. And that's it. I don't need anything else, because I've taken away the x cubed that was over there by throwing it onto the left side. So I get here then that I get x cubed is equal to 343. So in order to get x, I need to take the cube root of x cubed. But if I'm taking the cube root of this side, I also need to take the cube root of that side. Right, so we get the cube root of x cubed, well, that's just going to be x, is equal to the cube root of 343, right? The cube root of 343. And if you remember that from when we were working with exponents, or you could sort of use trial and error to figure out what that is, or a calculator if you have it on you, you should get that the cube root of 343 is 7. So we should get, in this case, that x is equal to 7. Alright, so hopefully this is making sense. This problem is slightly different in that we ended up just solving for one of the variables right off the bat, and sometimes that'll work for your problem. If you've been given enough information to just straight up solve for one of the variables, go for it. Feel free to go ahead and solve for that variable right away. Sometimes your second equation will just be the value of one of the variables. So your first equation will look something like this y equals 343 minus x cubed, and then your second equation just says y equals some number. So in this case, I could have just given you y equals 0 as the second equation, and it would have worked out just the same. So hopefully that makes sense. We've got another problem done here with x being slightly more complicated to solve because we were dealing with cube roots this time, but it's nothing unlike things that we've seen or discussed before. Alright, so that leaves us with just one more problem for today. I guess this video might end up being a smidge shorter than some of the other ones. We'll get into longer ones soon enough. I'm going to have a bit of a busy weekend ahead of me here, so your next videos might be posted a little while later, but given that we're at the time of recording approaching the holidays, I imagine that shouldn't be a huge issue for you guys. But yeah, I'm going to try and keep uploading videos over the break fairly regularly. I've got a couple things to do over the break, but other than that, I'll be reasonably free to record more of these for you guys. So, here's the last problem, basically the last problem that we'll be covering before the break. There might be a bit of a surprise lesson coming your way in the next couple of days. I know I'd sort of planned this out a couple of months ago and nothing really materialized, but hopefully something will come of it this time. If not, something will come of it in the next month or two, hopefully. But yeah, so this is basically going to be your last problem before the winter break, as far as I know, at least at the time of recording. You guys might be on a different video right now. But anyway, last problem, problem 4. Your first equation for this one is 14x plus y equals 7y plus 6. Alright, and then your second equation in this one, I just decided to keep things simple again. Y is equal to 2x. No problems there. Alright, so there are two ways you could go about this actually. I mean, there are several ways that you could tackle each of these problems. Now, since the second equation here has just given us y is equal to blah blah blah, we can just go ahead and sub that in. But if you were feeling like it, you could rearrange this equation so that you have x by itself, and the only reason I'm suggesting that for this problem is because in equation 1 we have less x's. So if you wanted to write x in terms of y, that's less things that you would have to replace in equation 1. Like if you get this thing is the same as x is equal to y divided by 2. This one over here, equation 2, is the same thing as that over there. It's conveying the same information, but now if you've solved for x so that you've got x all alone, this is only one place up in equation 1 that you have to sub that in. But if we keep it the original way, then we have to sub that in two different places, for y on the left side and y on the right side. Alternatively, you could deal with equation 1 first, rearrange it a little bit so that you've got the y's condensed down to just one term involving y, and then feel free to solve it however you want from there. I'm going to do it in possibly the most inefficient way in terms of that number of times we have to substitute things, is without rearranging equation 1 and without rearranging equation 2, I'm just going to take this information and throw it up in equation 1. So we're going to use equation 1 for the most part, and I'm going to sub equation 2 into equation 1. Alright, so if I sub equation 2 into equation 1, that means anywhere I see a y, I need to replace it with 2x. And so I'm going to do it this way just because it's this one will, I guess, sort of involve the most substitution of stuff. I'm confident that you guys could group together these two terms involving y's, or that you could reorder this in terms of so that it's x by itself equals something. But the substitution stuff is really the thing that's new, so I'm going to do it in the way that involves the most substitution. So, subbing in the fact that y is equal to 2x up in equation 1 means that anywhere I see a y, I have to replace it with 2x. So the first term doesn't change, I'm still left with 14x, but then I've got plus y, so that is going to become plus 2x, and then that's going to equal 7. Well, it was originally 7y, so now it's going to be 7 times 2x plus 6. Alright, so now we've subbed in this 2x here came from what used to be a y, and this 2x in here came from what used to be a y. So now we can go ahead and combine our terms with x's and see what we get out of it. So if we add up these ones on the left side, we get 16x. If we do the multiplication over there, we get 7 times 2x is going to give us 14x plus 6. Now we're back to just an equation with a single variable. I don't want the x's to be on both sides, so I'm going to bring the 14x over to the left side, and that'll mean it becomes negative when I bring it across the equal sign, because it was positive over there. So we end up with 16x minus 14x equals, and the only thing left on the right hand side is 6. So we end up with 16x minus 14x is equal to 6. Now if we deal with this left side, we'll be left with 16x minus 14x is going to leave us with just 2x is equal to 6. So the two ways you could think about this is you could divide both sides by 2 and be left with whatever x is equal to, or you could think of this as 2 multiplied by what number is going to give me 6. And if you go through that process, if you go through either process, you should come out to x is equal to 3 in this particular problem. So we get x is equal to 3, and that's mostly using equation 1. Now we're going to sub that back into equation 2 to solve for y. So we know y is equal to, so we're using equation 2 now, so y is equal to 2x. But we know x is equal to positive 3, so it's going to be y is equal to 2 times 3, so that means y is equal to 6. And to double check your answers for x and y, you could always throw them back into equation 1 and equation 2 and see that they both make sense. Now, the y value being 6 should definitely make sense with equation 2 because we used equation 2 to solve it, but we should double check, since we used equation 2 to get our final answer, we should double check by throwing both of those back into equation 1 and seeing if it works. And if you do that, you should get, let's see, 14x here, that's going to be 42, plus 6 is going to be 48, and then over there, 7 6s are 42, plus 6 is 48. So you should get 48 equals 48 up on the top if you sub in the values that we got just now for x and y. Alright, so that's 4 practice problems. They're all very similar to the ones we did before this. So this is the last sort of lesson that I had outlined that needed to be recorded before the break. So it might seem a little bit jumbled in the not-so-distant future, just because I'd originally planned, just a couple of fun lessons, things that we're not going to be talking about later, like things that I'm not going to test you on, just fun little neat tricks with math for a video or two. And then the next videos that I was going to make were going to be review ones to kick off math classes in January after you return from the break, which would be a review of the last few videos that we just did. So you might see, depending on when you see this, the next lesson might seem a little bit weird that, we just did working with one variable and now we've jumped to working with 2 variables, and the next video, if I don't update my plan, is going to jump back to reviewing working with 1 variable, and then we'll jump back to working with 2 variables. So it might seem a little bit jumbled. I'm going to refrain from recording for a couple of days until I can get that figured out and decide what exactly I need to change moving forward. But yeah, you guys might see a little bit of activity in the next couple of days if that surprise lesson sort of works out, but otherwise I will, I guess the videos are no longer really scheduled to take place this year, so enjoy the holidays, and you guys will be seeing this sometime in the new year, so hope you guys enjoy your break. Have a good one.